Hey YouTube, Jay Kilroy back with another project, quick little project, a machine fixing or modification project on my horizontal bandsaw. So let me take the camera over there, we're going to do a little hand holding, shake, rattle, and roll, but show you what's wrong with the saw and what we need to fix. So let's head on over. Alright, this is my Ellis 2000 bandsaw that I bought and used. It's a 11 inch cut. You can cut an 11 inch round at 90 degrees, 17 inch flat. It takes a 12 foot by 1 inch blade. I guess you would call this kind of a medium sized bandsaw. 1.5 horsepower motor. It does miter, swing on the axis there, and herein lies the problem. So you see I got a representative workpiece here, block of aluminum here. Let's say I wanted to cut that. Well, you look at my clamping setup here and you'll notice that let me raise the blade up here. So say I wanted to cut this in two. So I'm just catching that in the clamp. Got this. The clamp works great. So I got this clamp, but what happens as you lower the blade, let me move the block out of the way, you'll see that okay, everything looks fine. Okay, we're getting real close there as far as the blade goes. We're very close here, and look right here. The automatic cutoff hits this piece that the clamp was connected to. I don't believe this is original to the saw. I believe this clamp is. I don't believe this piece that it's sitting on is. That hits the automatic disconnect before the saw actually gets down flat. It prevents the saw from falling down flat and completing the cut. So this, and this isn't providing any function, so this needs to be shortened up. At least back to, say, equal to where this piece is here. We can shorten this up, say, 2 inches. We'll shorten that baby up 2 inches. That's in the way. And then I get interference here and interference here. So what I would like is, I'd like a wider jaw here so that I didn't have to get as close to the workpiece. Possibly, this is slides, right? I'd like a jaw possibly as wide as this piece that the clamp is on, which is about what? A-bomb approved hook scale, basically 4 inches, a little under 4 inches, that width. But I don't want to permanently modify the clamp. So what I'd like to do is I'd like to make a shoe that I can fit on here, tighten on, screw just to clamp it on temporarily, so that it could widen this jaw out so that I wouldn't have to slide over as far this way to hit the workpiece, and be able to hold shorter workpieces close to the blade. So that's what we're going to work on. And this, if you look down here, the center bar is what this thing rides on, and I'm thinking you can see the hokey mess that is the clamping arrangement. There's nothing on this side, right? There's a plate, looks like a couple of bolts that probably extend up in here. There's a plate with a couple of big huge nuts on them as spacers, and that's what, and all it does is basically keep it from coming up, right? It doesn't resist movement, I don't think, in any way. So I'm going to take this thing off. We're going to take this off and get it over to the workbench and see what we got, because I think there's probably 2 or 3 little things to fix here. Alright guys, gals, this is the clamp. Those big nuts that I thought were spacers were actually knobs. How you like that? Tasty, isn't it? Tasty welding. Couple little flange nuts welded onto the back of these big nuts, and well, the best thing I can say about them, I guess this isn't bad, is they worked. And these 2 pieces, let me turn it around here. So these 2 nuts were on here, like so. And then these 2 flat bars were all that held the back of the vise up, keep it from lifting. This bar here, this threaded bar here that just went straight down, there's a cross member that goes right here. This is the only thing that resisted the backward force. There was nothing on the bottom here. And then, like I said, these 2 pieces here and these pieces of threaded rod were the only things that kept the vise from rising up. And you know, I've had this thing for several years. It's performed flawlessly for me for the most part. You know, this isn't really a fix where I'm fixing something that's broken. It's more like a modification just so that it works a little better for me. So I really can't complain, especially not when you consider what I paid for it. So, but as you might expect, all these parts here are going away. So I will not be putting these back on, or these back on. In fact, go ahead and do a little, I'm going to keep those little flat pieces for something, but this hodgepodge here is going to trash. So now, part 3 of this, besides shortening this piece here, making a jaw shoe to give me a wider jaw, you can see where somebody's, you can see where somebody's cut this before, and so task 1, shortening this. Task 2, making this jaw shoe. Task 3 is now creating new hold down system, which we'll have to design from scratch. I may try to get online and see if I can find some documentation on the Ellis saws that provide enough detail for me to see what was there from the factory. I certainly know that wasn't it. So we will have to design a new hold down mechanism here. So first thing we're going to do is shorten this bar here 2 inches. So we're going to take this vise, this clamp off of here. So let me get some tools. Alright, we'll do a little disassembly here. We got El Cheapo Husky 3/8" air ratchet. If you're using air tools, remember, wear eye protection, oil your tools. This stuff's great here, by the way. Senko pneumatic tool oil, fantastic. Oil your tools and wear hearing protection. If you think it's loud, it is. You aren't going to be a sissy if you put on a pair of these big honkers here. Shorten this piece here 2 inches. Alright, we're back over at the saw. We got our piece clamped up here. Woohoo! I'm hand holding. We're going to cut this. I've got the, here you can see this auto shut off right here that hits this arced piece, right? And this extended over that and was interfering with the auto shut off. This is the power switch right here. Right. I've got the saw in the slowest speed, and got my intermediate support set, and we're gonna cut it on through there. Be back with you here in just a little bit. Alright, we got that cut off of there, and that edge is going to get some file work before it goes back on the saw. Let me get that phone. Okay guys, we're back over at the bench, and getting the coffee. I've started cleaning this up. You see I've cut this stud off. It goes all the way through the block, and it's welded on the back side, and I just didn't feel like drilling it. We're going to be milling a slot right in that location anyway, so I'm really just, you know, not worried about it. So I got out the little 90-degree angle here and just started cleaning this up. Using a roll lock style disc there, you know, on an arbor. I can't really just drop this thing into the mill and clean it up completely because I don't want to lose any thickness, because this raises the clamping mechanism up the equivalent height of the spoil board. The spoil board's made out of a piece of 1/2-inch aluminum, so I've already replaced that once in the past. And so I've got to leave the total thickness here, but you know, I don't want to do mark out on lines. So I decided to clean it up a little bit and deburr my cut in down here. These little roll lock discs, especially the coarse varieties, are great for deburring. They will remove some metal and make some sparks, so but they do make a bit of a mess. Anyway, so we're going to mark out right here where we're going to mill a slot for our key. So we got to do 2 things. We got to figure out how big the key is going to be, and we've got to mark the surface here once we figure that out. So let me go over to the back over the bandsaw and figure out how big we're going to make this thing. Alright, I went over to the bandsaw and I took a piece of 1/2-inch high-speed steel. This is a 1/2 by 13, so I'm just, you know, guessing, hey, 1/2 inch is going to work. Took a piece of 1/2-inch high-speed steel blank I had sitting around and just slid it up and down through the grooves. It is a little tight right near the outer edges, because the welded frame there is not perfectly square. So I really don't know if I want to go with a 1/2 inch or maybe a little bit smaller than a 1/2 inch. I'm going to try it with a 1/2 inch, and you know, if it causes me an issue in the future, I can always trim the key down a little bit. But so what we're going to do, we want to be centered. What I'm going to do right now is I'm just going to draw a line down both sides of this stud here. Just using that because we want to be centered on the location of that stud. And just butt up to the thing. Get a good scribe going there. This other side is going to be kind of tricky. So that's where we want to center it. This is where we want to center our slot. All right, we're getting set up here over at the mill. What I've got in here is a ER40 collet setup in the vertical spindle. I try to keep a collet setup of some sort. In here I've got three different collet setups that will work in this spindle. I've got a ER40, I've got a TG150 for bigger stuff, and I've got a TG75 for smaller stuff. The ER40 is the most flexible. The TG stuff offers a better grip for when you're really hogging, but this isn't that time. And the reason I try to keep a collet set up in here is because it's such a pain in the jump to change tooling in this thing. So here's the drawbar wrench, right? And here's the ladder. So it's a lot of work to change tooling in the vertical spindle, especially if you have the head oriented, something funny or whatever. I mean, I'm standing flat on the ground, right? And so it can be somewhat of a lot of work, and it'll slow you down. And if you're doing just fun projects, you know, lots of times you're like, oh, well, you don't want your machines to keep you from working. The cutting tool we're going to use today is just a regular 4-flute center cutting carbide end mill. This particular one's from Tool. I don't even know if they're still around. Got a bunch of these. This is bread and butter cutting tool right here. You know, people talk a lot about you know, not using carbide in a home shop machines. That's baloney, right? Oh, you need real rigid machines to use carbide. Yeah, well, maybe if you're using a little 1/8" carbide end mill, you know, it might be handy if you have 25,000 RPMs and CNC machine to control your feeds. Otherwise, it goes tink and shoots across the room. But with larger stuff like this, you know, carbide is a moneymaker as far as I'm concerned, because they last in the home shop environment or in a non-production environment. These things last forever, right? Versus having to get stuff sharpened, and you can have these sharpened. So I think it's a good investment, honestly. You know, high-speed steel and cobalt-type steels go the way of the dinosaur when it comes to real production, you know, big production shops. This stuff just gets cheaper. So anyway, we're using that in this ER40 setup. What most people do with their collet setups, especially the ER collet setups, is they under-torque them. So make sure when you torque this thing up that you put some stones behind it. I think the torque spec for the ER40 is 140 foot-pounds. Somebody correct me if I'm wrong, but I think that's what it is. So we got our machine set up here, ready to go. I'm gonna go ahead and get my standoffs and my workpiece, and we'll get set up to make the cut. Alrighty, I get the camera moved around here. We got our end mill mounted. We got the overhead column, the vertical spindle active. We're going to make some chips. First thing we're going to do is we're going to get rid of this stub and get lined up, get rid of that stub, and then we're going to make our groove cut. You gotta watch out. Make sure your rapid doesn't move your camera. Yeah, it's telling me my workpiece isn't level because it's not a flat piece because I'm not cutting evenly on both sides. So that's not a big shocker, however. Alright, move the camera around. Back from the mill, taking the ever trusty little roll lock there. I've deburred this piece here, cleaned this piece up, and got what I have here is the piece we cut off from the other end to keep it from hitting the automatic cutoff, and I'm going to turn that into the key. Now it's too thick by 1/4 of an inch for the job, so we're going to have to cut some metal off of here. And you might be asking, well, why in the world would you spend all the time doing that? Well, I got to cut the metal off of something because, as it turns out, I don't have anything 1/2 inch square, which blows my mind. So besides needing to make a note to myself to order some stock come tomorrow, I need to carve this down. So we're going to go back over to the mill and we're going to make this a 1/4 inch thinner. guys, got my camera going back again. So no more of those awful cell phone pictures. Let me tilt the camera down here. Okay, so we got our piece thinned out, and we're going to drill and tap this top to put a couple of 1/4 by 20 fasteners in through from the top to hold this key in place. So we are centered on the slot, and we have picked up 0 on the back. Alright, so we picked up our 0, went ahead and set that properly to compensate for the edge of the edge finder. Come in 1 inch. We're going to spot and drill. We're going to do one at 1 inch. We're going to do one at 2 3/4 inches, which is 1 inch back from this side here. That's 2 3/4. Make some room for a longer drill. We're using a size F clearance drill, 257. Give us a little leeway there. Oop. There is the phone. So we went ahead and, just to be certain that we got the center, we picked up both sides on the Y, and we picked up the end here so we can space our holes out. Alright, we got our spotting drill back in here. I'm not being smart because this is a tap drill for 1/4 by 20. So alright, let's go find us a 1/4 by 20 tap. Okay, I'm tapping this right here with a 1/4 by 20 spiral flute tap, and you see the chips coming out here. Pushes the chips right out. Alrighty. Let's see how she fits. Chips down in there. There we go. Okay, there we are. Bandsaw modification number 2 is complete. This will replace that piece of threaded rod that was coming through there. So let's take it over to the saw and let's give it a try out. Alright, we got the vise with the new key in here. It slides back and forth nicely. It does keep it oriented a lot better than the threaded rod. Without anything back here to hold the vise, we do get some lift, right? So we're going to have to definitely put something back here in order to prevent that lift. So that is the next project and the next video. So but as far as the stop goes, you no longer have to worry about the stop hitting the back of that thing, so the saw will go all the way down and disconnect the power automatically. So that's rectified. We've replaced that chintzy threaded rod that was in the front here, and all that's left to do right now is to build another retention mechanism to clamp around this square member here. So that'll be Ellis Bandsaw mod video number 2. So see you soon. Be safe in the shop.